Hello and welcome to yet another video by Pale Blue Thoughts. Let me start by wishing all my viewers a happy Independence Day. Last week we had started on discussing about the pale blue dot, our only known home, and about the solar system which we are part of. We had tried to get a bird's eye view of the solar system, and I hope you found that perspective interesting. We had also tried to get a feel about the sizes and distances of these planets, and I hope you got the feel that I intended. We had stopped at the distinction between inner and outer planets. Today, we will see some distinct characteristics about the planets and also see how planets were formed, and if time permits, we will also see how the pale blue dot was also formed. Before we start to discuss about the beginnings of our solar system, let us discuss a bit about the planets so that we get ready to get the right feel when they all start to form. To make it easier, let's keep the inner and outer planets separate and see how they differ. The inner planets of Mercury, Venus, Earth and Mars are smaller in size and mass when you compare them with the outer planets of Jupiter, Saturn, Uranus and Neptune. The composition of all inner planets are mostly rocky and contain many heavier elements like metals, iron, silica, carbon, etc., whereas the outer planets consist of lighter elements like hydrogen, helium, mostly gases. Why is this? Blame the sun. The sun sends out huge amount of energy and particles in a steady stream called stellar winds. These winds are so strong that they blow off most of the lighter gases of the four planets closest to the sun, leaving them smaller with only their rocks and metals intact. That is why they are rocky or terrestrial planets. So it is not that the inner planets came to be formed close to the sun. It is that only such planets can stay close to the sun. The four outer planets are so far from the sun that its winds cannot blow away their ice and gases. Hence, they remained gaseous with only a small rocky core. So that is how the outer planets became so big, as the influence of the sun is much lower and the lighter elements with which they have been formed are not likely to be affected by solar winds. Whereas the inner planets have a solid surface due to the presence of rocks and heavier elements, the outer planets, although huge in size, are said to contain no solid surface. Though we have been able to land on the moon and also on Mars, all space probes sent to Jupiter, Saturn, etc. have just dropped into the gaseous atmospheres of these planets and burnt out due to friction without ever touching a solid surface. Although they appear to be bigger and bulkier like Hulk, inside they are mostly like this. In fact, if you can have a big water tank and throw Saturn into it, it will float on the surface as the density of Saturn is less than that of water. We discussed the number of moons of inner planet last time, that the inner planets have either no moons like Mercury and Venus, and Earth has a solitary one and Mars has two borrowed ones. The outer planets have many moons or natural satellites revolving around them. Another important aspect is rings. No inner planets have rings around them, but all outer planets have rings. You may have studied that the only ringed planet is Saturn. This is not true. All outer planets have rings because of the great number of smaller bodies spinning around them. It is only Saturn which has a very conspicuous or an eye-catching ring. So that is yet another misconception busted. So, now let us see how these gaseous giants and rocky dwarf orbs were formed in space. The Nebular hypothesis is the most widely accepted model in the field of cosmogony to explain the formation and evolution of the solar system, as well as other planetary systems. It suggests that the solar system is formed from gas and dust orbiting the sun. The hypothesis was developed by Immanuel Kant and published in his Universal Natural History and Theory of the Heavens in 1755 and then modified in 1796 by Pierre Laplace. originally applied to the solar system, the process of planetary system formation is now thought to be at work throughout the universe. Please remember that this is not a theory as yet, but it is widely accepted as the most trustable model to explain the formation of the solar system and its other elements. So let's go back in time, some 460 crore years or 4.6 billion years back. I know it's difficult for you to picturize 4.6 billion years in your mind. If you sat and counted from 1 to a billion and you started now, it would take you approximately 30 years to finish, going at a rate of 1 number per second without pausing for food and water and not sleeping. Do that 4.6 times without stopping to die in between, which is very important of course, and you will count to 4.6 billion in about 140 years. Picturizing this time scale is almost impossible for us humans, which is why we still have people doubting the Big Bang theory and the theory of evolution. For many, it is simply gazillion years ago. So the start of the solar system occurred 460 crore years or 4.6 billion years ago. We found this out by determining the age of stony materials from the asteroid belt. There was no sun, no planets, but just a gaseous cloud-like expanse which stretched to many light years. We call them as nebulae. You can even now see other such spaces now in the universe. Those pretty pictures that you sometimes put as your desktop background are the first stages of solar systems just like ours. So picturize this dense cloud of gas and dust, mostly hydrogen and helium, with a small percentage of heavier elements floating aimlessly in the universe. These heavier atoms had been formed earlier in the history of the universe when other stars aged and died. Now the laws of physics existed around that time, and slowly the particles came closer and closer due to gravitational force. And due to gravity, these clouds of dust and gas stuck together, forming bigger matter. Now as the matter grew in size, so will its gravity. So it starts to attract matter from further away and the mass grows bigger. Again the gravity increases and more neighboring materials fall into this body, and we call this a gravitational collapse. So this process happened in many parts of the nebulae, all due to one force, gravity. Gravity is a neutral force in that it happens between any two masses. There is no distinction between what it attracts. As long as there is mass, it will attract anything to its center. If you are a big mass, your gravity is enough to crush you into yourself. If there is a mass at the center, it attracts the matter from all its outer edges to its center. And this happens from all sides. So if all points of a matter is pulled into the center equally, what do you think the shape of the object will end up as? A sphere, or technically a spheroid. That is why all bigger objects in the universe end up being spheres. It is gravity which gives planets and sun and stars a round shape, as it attracts everything towards its center from all sides. Now as more and more matter gets accumulated, the internal pressure increases. And as pressure increases, something else also increases, the temperature. So at the center of the ball, as pressure increases, the core temperature also increases. Remember, these are mainly hydrogen and helium atoms which were floating around the nebulae, which are now forced into a smaller space due to gravity. The atoms, once separated, began to jostle each other, generating heat. In the rising heat, the atoms collided more frequently and more violently. Eventually, they reached a temperature at which the protons at the center of the atoms began to fuse in a thermonuclear reaction process which we call as nuclear fusion. When you try and combine two or more atoms under pressure, they tend to fuse into one and release energy as a byproduct. So as the mass of an object gets bigger and bigger, due to this thermonuclear reaction, there is a great amount of energy which is produced within the core or the center of the object. Now the game changes. So far, it was a one-man show of gravity which was running the show. Now with nuclear fusion coming into the picture, there is an outward push from the center to the outside. So now there are two lions in the forest. Gravity trying to pull things into its center, and nuclear fusion trying to push energy from inside to outside. This process continues to increase as the body increases in size. Finally, at one point, both these contradicting forces reach a point where they achieve a balance where both the forces become equal. This causes the body to stop becoming bigger and starts to release the energy from the center to the outside. Then we can say that a star is born, and that is how our sun was formed. The process, which I explained in less than 5 minutes, actually took 15 million years or 5 crore years. The material in the nebulae, not absorbed into the sun, swirled around it into a flat disk of dust and gas, held in orbit by the sun's gravity. This disk is called an accretion disk. Each planet began as microscopic grains of dust in the accretion disk. The atoms and molecules began to stick together or accrete into larger particles. So these materials, which lost out in getting admission into the University of Sun, started to collect their own dust particles in order to grow bigger. Objects which lost out in collecting enough particles to gain mass and become a big ball remained in irregular shapes due to not having enough gravity, and we call them asteroids or minor planets. As they were growing up, they lacked sufficient nutrition, dust and gases of course, to grow bigger and ended up in the asteroid belt. Now there is a curious reason as to why this asteroid belt ended up between Mars and Jupiter. Jupiter, if you remember, is almost a tenth the size of the Sun. Had it tried a little bit harder, or had there been sufficient materials around, it would have also become a star like the Sun. It is like the person who got 9,99,000 rupees. He could have become a millionaire, but he is a few rupees short. Now another issue that we often encounter is when you try to explain the solar system in terms of sun being the dad and planets being obedient sons and daughters. The problem is that in this case, the so-called dad and children were born together. In a solar system, the order of formation is not sun first and planet next. It all happens simultaneously. Now when you hear the word solar system, what is the picture that comes up into your mind? Sun and 8 planets? Then that notion needs to change, because the solar system is not just Sun and 8 planets. There are many other celestial objects such as dwarf planets, natural satellites, asteroid belts, comets, and the Oort cloud, which is part of a known solar system. Let us see them one by one. There are some objects which hasn't reached a huge size but have achieved a spherical shape. They are not able to revolve around the sun in the way normal planets behave. To get called as a planet, you need to have 3 necessary criteria. It should have a separate orbit around a star, and it should be big enough to force it into a spherical shape. The third criteria is that the planet ought to clean away all the debris around it and should have a clean neighborhood. Cleaning the neighborhood around a celestial body's orbit describes the body becoming so gravitationally dominant such that there are no other bodies of comparable size other than its natural satellites or those otherwise under gravitational influence. Any other objects which are spherical but have a different orbit are called dwarf planets. In 2006, the International Astronomical Union decided to define the term planet formally during the General Assembly. This definition led to the declassification of the planetary status of Pluto and gave it the title of a dwarf planet. What did it do wrong? When Pluto was discovered, the world was obsessed with discovering new planets, so it was inducted into the school. But very soon we realized that at times it jumps into the orbital plane of Neptune and tries to become the 8th planet from the Sun. Also, it hasn't done a good job of clearing its neighborhood of astronomical debris. This was not permissible as per the rules set out by IAU, and they rusticated poor Pluto as a dwarf planet. the effects of bad housekeeping and disobedience. But the crucial point is, the definition has been set by us humans, and this has had no effect on Pluto. We are classifying these things for our convenience. Tomorrow, you can call Saturn as a dwarf planet as long as it is accepted by others. You can call Pluto as Rahul or Prem, but it won't affect it one bit. It still continues to do its own thing as it did earlier and doesn't seem to be affected by what we call it. Another interesting aspect is that Pluto was discovered in 1930 and its orbital period is 248 years. This means that ever since its discovery, it hasn't yet made a single revolution around the Sun. There are currently 5 dwarf planets as recognized by the International Astronomical Union: Pluto, Ceres, Aries, Makemake, and Huamia. There are many more that have been classified as most likely dwarf planets and maybe will get added to the list as we make more flybys past them. Okay, so what are satellites? A natural satellite is an astronomical body that orbits a planet, dwarf planet, or small solar system body. They have also developed in the same way as other planets through gravitational collapse, but because they were formed closer to a bigger planet and thus got attracted to the gravitational pull of that planet, they started revolving around that planet instead of the Sun. While natural satellites are often colloquially referred to as moons, there is only the moon of Earth. A planet usually has at least around 10,000 times the mass of any natural satellites that orbit it, with a correspondingly much larger diameter. The Earth-Moon system is the unique exception in the solar system. At 3,474 kilometers across, the Moon is a quarter of the diameter of Earth, and this is a definite exception. In olden days, they were simply called as satellites until we started sending some up ourselves. So now we have artificial satellites and natural satellites. Now it is not easy to maintain a satellite for those planets which are closer to the Sun, because the Sun is such a giant ball with gigantic gravity. Either a satellite would get pulled by the Sun or it might dash into the planet. So that is why inner planets don't have many satellites, whereas the outer planets, which are far away from the nuisance of the Sun, have many satellites orbiting them. So how do we send artificial satellites? Here too, we use the same method that we see in the universe. Natural satellites orbit a planet because it is influenced by the gravitational pull of the planet, and because of its size, its own gravity and distance, it is not falling into the planet but is circling the planet. We use the same method to send artificial satellites. We put our satellites in an area where the gravity of the planet will not pull it towards it, but because of the position, the planet starts to treat it as a natural satellite and makes it go around it in an orbit. The position is very precise that it should be able to be just as close so that it doesn't fly by but enable us to take pictures, study the planet in detail, etc., but not too close that it gets pulled into the planet. Science enables us to calculate such distances with exact precision, and that is why we have managed to duplicate what is found in nature. Between the inner and outer planets lies an area filled with millions of asteroids, small, rocky, icy, and metallic bodies left over from the formation of the solar system. No planet formed in this area. Astronomers theorize that Jupiter's gravity influenced this region so much that no large planet could take shape. Jupiter is 10 times the size in diameter of Earth and more than twice as big as all the other planets combined. It is almost large enough to have become a star, so it literally did not allow another planet to flourish in its gravitational region. The 2 moons of Mars are actually borrowed objects from the asteroid belt. Named as Phobos and Deimos, they do not have a spherical shape like the other natural satellites but have the shape of asteroids. There is actually another belt which is situated outside the orbit of Neptune too. Our little Pluto is actually a member of this belt, and it is called the Kuiper belt. Next are comets, and I have discussed this in detail in an earlier video titled Meteor Trails and Comet Tails, and you can watch that video to learn more about comets and the tales about their tails. The final thing known in the solar system which is left to be discussed is the Oort cloud. The Oort cloud is the most distant region known in the solar system. It is actually the remnants of the nebulae that created all the planets. Just like we deposit leftover food in a bin outside our house, the solar system too dumped a lot of leftover debris from making the solar system at the very edge of the solar system. All the planets formed 4.6 billion years ago. The region in which they all formed still contained lots of leftover chunks called planetesimals. Planetesimals formed from the same material as planets did. The gravity of these planets, primarily Jupiter, then scattered the planetesimals every which way. Some planetesimals were ejected from the solar system entirely, while others were flung into eccentric orbits where they were still held by the sun's gravity and the tidal force of the galaxy itself. Just to give you an idea about the distance of the Oort cloud, Pluto is situated between 30 and 50 astronomical units from the sun. The inner edge of the Oort cloud, however, is thought to be located between 2000 and 5000 AU from the sun, while the outer edge being located somewhere between 10,000 and 1 lakh AU from the sun. Well, at least the planets knew where to fling their garbage. They have flung the garbage very far away from the neighborhood. Oh blimey, look at the time. I think I won't be able to cover the story of the Earth today as we have overshot the time, so that story will have to wait. So the entire point of this video was to educate you that the solar system is not just about Sun and its 8 planets, and that there are plenty of other neighbors in our community. There are more things to discuss, including the beginnings of the Earth and why planets keep rotating. I will be back with yet another interesting episode about the pale blue dot in order to get you the real feel about the world we live in. And until then, it's bye-bye from Pale Blue Thoughts.